going to discuss exam 2 as far as the answers for the problem, the 7 problems as far as scoring them. What I did, I'll go through it, but basically what I did is if you had the correct answer, I give you full credit, including the units. If you had the units wrong, such as an acceleration is say 5 meters per second squared, I accepted 5 meters per second that way, but if you did like 5 meters per second, that's velocity, so that would be half a point I would deduct. So that was the case there. It's always helpful if you show your work, because if you showed your work and made a slight mistake, if you did everything, entered the correct numbers, had the right formula, did it correctly, but somehow entered a number wrong, or used the wrong number, like one problem where some people, the velocity of launching was 24 meters per second, but some of you used 20 for whatever reason, but you did the problem exactly correct, got the different answer. I gave you full credit for that, because you're showing me you know what you're doing, but you entered the wrong number. So if you just have a number, it's hard and it's wrong, and usually I give you like 1 out of 3, 1 out of 4 or something. I wasn't overly concerned about significant figures. It was good what some of you did that. And so that's the case there. All right, so I'm going to go through it. And so this will be start with problem 17. So this link, this will be under the exam 2. So this video will be posted. So problem 17. And before I say that, I have posted the answers for the first 16 multiple choice questions. For those of you can check the submission for that, so you can see what the answers were for that. All right, so problem 17, we have 3 forces. This is 1. Is that 1? Oh, that's 3. It's 3, 2, and 1. All right, this is at 30 degrees. This one is at, let's see, F1 is 80. This is F2 is 60. And F3 is 40. Try to get this a little bit better to scale. So the way to do these is do tail to head, tail to head, tail to head. So if I want to get it more precise, I'll make each one approximately 8 inches long. So that would make this out to about here. All right, 30 degrees. And then I'll take 2, it's vertical, that would be 6. Then this is 4. All right, the net result would be approximately this number, which corresponds to 3.5 inches, so about 35 newtons, and the angle is approximately 34 degrees. This would be the result, 35 newtons at 34 degrees. All right, so that's the answer there. If you did the component method but made a mistake, somewhere I gave you anywhere from 2 to 3 points. If you just had a number, I usually took nothing. So you could have used a FED program to do this. You could just scale like I did here. So that was problem 17. All right, problem 18, that was worth 4 points. All right, problem 18. All right, problem 18. All right, for this particular one, we shoot it off at 10 meters per second is V naught, and it lands somewhere out here. Time is 4.3 seconds. All right, how far did it land? All right, X is going to be V naught times T, because in the X direction there's no acceleration. This would be 10 times 4.3 would be 43 meters. Or some of you said, because this is technically one significant figure, some of you then rounded it to 40 meters, which is perfectly correct. So the answer would be 43. All right, so that's problem 18. Problem 19 now is worth 2 points for problem 18. Problem 19 is the same problem. All right, what is the height of the cliff? All right, so gravity is now acting in this direction. All right, for this part, we have y, because V naught in the y direction is 0. This is in the x direction. So we're going to have y is going to be 1/2 gt squared, using our equations of motion chapter 2. To make it simple, I use g is 10 meters per second, or minus 10 meters per second. I would get, this would be negative then. So I would get y is 1/2 times 10 times 4.3 seconds squared, which turns out to be about 92 meters. All right. If you use 9.8, get like 90.6 or so. So it's about 92 meters. If you round it to actually the lowest, because of, oh, no, that would be correct, 92 meters, because this is 4.3 seconds. All right, so that is problem 19. Now it's worth 3 points. All right. Okay, so I'll leave that up for a second. Problem 18 is 43 meters. Problem 19 is 92 meters. 2 points, 3 points. All right, moving on to problem 20. All right, problem 20 then. All right, for this question, okay. It's moving in a circle. Mass is 1,000 kilograms. All right. And it's moving at a speed of velocity of 30 meters per second, which is approximately 67 miles per hour. You don't use that because we're in metric. It has a diameter is 200 meters, so the radius is 200 over 2 is 100 meters. All right. If you used the diameter instead of the radius, I took off half a point, because otherwise you did the problem right. But the radius is 100 meters, so you have to keep that in mind. So R is 100. All right, the frictional force to keep it on, the frictional force is pulling it inwards, and for it to stay on the road, the frictional force must be at least equal to the centripetal force. We don't know what the coefficient of coefficient of friction is for this road, but we're going to need to know. We could calculate that, but all we need to know is this has to be at least equal to that. So the frictional force has to be equal to at least mv squared over r. So it'll be 1,000 times 30 squared over 100 is 9,000 newtons. All right. Keeping that in mind, this would then be equal to, some of you this is the correct answer. But if I want to get the coefficient of friction, the minimum, that would be mu mg, all right? So that would be, which would be mu, and I'm going to use, this would be 1,000 times 9.8, which would be mu is 9,800 is 9,000. So mu would be approximately 0.92. All right, but that's not what the question was asking. I didn't ask, if somebody actually did put in the coefficient of friction, is this, I would give you full credit, but whoever put this in, they put in, it was this force. This is the coefficient of friction. And it's a dimensionless number. There's no number associated with that. So you would have to have relatively good conditions to be able to make that turn. So that is problem 20, and that was 3 points. All right. Problem 21. Well, again, this was a correct answer for that. Problem 21. I mean, it's possible in the final, before I go on to 21, that I could have a question related to cup for that type of problem. All right, so moving on to problem 21, then this would be, all right, this is the block hanging over. This is 63 kilograms, this is 10. All right, in this problem, we have, again, F equals mass times acceleration. All right, both of them are being accelerated, so that's going to be 10 plus 63 times A. But this would be mg, but the only thing accelerating downwards is just the 63. So it's going to be 63 times 10. I'm just going to use that. Is 73 times A. This is kilograms. So that's going to be 630 over 73 is acceleration is approximately 8.5 meters per second squared. That would be what you would get for full credit. Now some of you put in, had this, like this problem where 10, all right, 63 and 10, in that case, the mass being pulled, these would counteract each other. So in that case, this mass on this side, this mg, would be 63 minus 10 times g. So you'd end up with 53. So if you did the problem this way, it'd be 53, be 530. In that case, you would get, instead of 8.5, you get 530. Let me leave that up, because that's the correct problem. 530 over 73. A would be approximately 7.5 meters per second. So if you showed your work to get this, I took half a point off, all right? Because you did it basically correct, except you added this. If you just put this number down and didn't show any work, I gave you only 2 points, 2 out of 3. So that was 21. So the correct answer is this, because of this configuration. But for those of you that did it this way, depending on how much work you showed, again, showing work helps a lot because that shows I know what you're talking about. That would be the correct answer, but that's not the correct answer. This is. That's problem 21. Problem 22. Okay. Problem 22 is we have a car, mass of 1,000 kilograms with V naught is 24 meters per second. And this is the problem where some of you, for some other reason, use 20. Maybe that's from the word problem or something. I don't remember. Anyway, the coefficient of friction is 0.8. How far does it take to stop if we slam the brakes on? Okay. How far does it take to stop? All right, this goes back to our expressions from chapter 2. So V squared is V naught squared plus 2AX. All right. Right. So this will be 0 because it stopped. This is 24 squared. And then A, at mass times acceleration will be, what it actually will accelerate will be mu mg. Mass cancels out, so that doesn't make any difference, because it makes no difference whether it weighs 1,000 kilograms or 100 kilograms. It makes no difference. So you can eliminate that. So the acceleration backwards. So the acceleration is going to be 0.8 times 10, I'm going to use that, would be minus 8 meters per second squared because it's slowing down. It's opposite. So that would be 2 times minus 8 times x. That would be 6, putting that on the other side. 16x is 24 squared. And that would be, then x is, divide both sides by x, so I get 36.7 meters. Or 37 meters, about 37 meters. Okay, so that is problem 22. Right. All right. Problem 23. Final problem. All right. Okay, this is a range problem. It goes, R is 110 meters, is shot at an angle of 50 degrees, and the question is, how fast is it actually shot to actually do that, go that far, all right? So it's range, you use our range expression because it lands at the same height that it launched at. So this is V naught squared times sine of 2 theta over g. So we're going to so 110 equals V naught squared times sine of 2 times 50. So it'll be 2 times 50, not sine. So you got to do that correct. And again, over 10 for g, I use 10 meters per second squared. This turns out to be 110 times 10 divided by sine of 2 times 50, which I don't have, is v squared. So v naught turned out to be about 33 meters per second. All right, you can calculate this yourself. This is sine of 100, which is a little bit more, a little less than 1. So the answer is about 33 meters per second. So that was problem There, again, if you show work, again, it's slightly wrong, then I would give you more credit than just having a number. If you had the wrong number, I usually give you 1 out of 3. If you show work for like all the problems and have the units correct, you would get most of the points, right? So that are the problems for the exam 2, as far as that's concerned. And let me know if you have any other questions. I've also posted the overall scores.